Welcome to this session about the command line tools of Wireshark. Who has known that there were command line tools? Nobody knows that there are command line tools with Wireshark, like tshark? Yeah, you know, okay. Well, Wireshark is the GUI version, but there's tshark, the command line version, and there are several other utilities that we're going to talk about, and how you can use them, and how you can use them with scripting to make your life easier, or to do stuff that you can't do with the GUI. So, a little bit about myself. I used to work for one of the first internet providers in Holland back in the 90s, and then I started working for a large bank, a reseller of equipment, and that's where I started using Ethereal back in the days, and nowadays Wireshark. And I became a core developer like 10 years ago, and since 9 years I have my own company doing troubleshooting for my customers. And next week I will be diving in Bali. So, this is what my company does. I do network troubleshooting, protocol analysis, and training. And well, enough of that. So first, well, the introduction we already had. So why do people want to use the CLI tools? Do you have any idea? Faster? Yeah, in a way. Other reasons? Cut large files into small files. Good point. Other reasons? Like sometimes you're on a system that doesn't have a GUI, so you need to. Or you want to automate things. We'll talk about that later. So we're going to talk what are the CLI tools, some useful shell commands that we can use, some scripting examples, and of course some questions. But feel free to ask questions in between, because I like the session to be interactive. So if you have a question, just shout out and come to me. So one of the reasons is when the GUI is not available. Of course, if you have a command line system that doesn't have an X server or anything, then tshark is all you get if you want to have full packet decodes. Somebody said it's quicker because you don't. Yeah, sometimes it is quicker. And it makes some analysis easy because you just have to type stuff and you don't need to click everywhere. But the main reason for me is to post-process the results. Like if I'm in a GUI, I just see what I get, and if I'm doing in a command line, I can post-process the things that come up. And so the GUI is very powerful and it's interactive, but it's limited and to its functionality that it has. And the CLI is very flexible. Okay. Another part that you might want to consider is automation. If you need to process capture files every day to extract certain types of information, you can make a script out of it and have it run every night or every hour or whatever. So some automation can be done with the command line tools. So it's not only when the CLI is not available, there's a multitude of purposes where you can use the CLI tools. So how are you going to do that? First of all, you need to know what is the information that I need. You need to have a purpose, like, I don't know, make an overview of average response times or whatever. You need to know what you need. And once you know what you need, you want to visualize how you want it, in what format, and then look at what the data sources are. Well, in my presentation, the data source is, of course, pcap files. But the same goes for processing log files or anything. But we're focusing on handling pcap files or pcap and G files. So you need to know the format. Well, in our case, we know our format and what tools are available. This is where you need to experiment a lot, because you need to get to know your tool. You need to get to know what it does, what the output is, and how you can post-process it. So one good source for that is the man pages. You can find them online or on your system, and do experiment and practice a lot and be creative. And what I'm going to do today is I'm going to show you some simple or some examples that get a little more complex every time, every step. Not that these examples are really interesting, but they show you a way that you can do stuff. So take along and see what you learn from it. So what are the CLI tools that Wireshark provides? Well, there's quite a lot, but the ones that I'm talking about is tshark, of course. It's the main one. Dumpcap. Who has used dumpcap on its own? 1, 2, yeah. Well, Hansang, of course. Cap infos, editcap, and mergecap. There's a few other tools that are distributed with Wireshark, but these are the ones that I'm using in this presentation. So first of all, what can tshark do? It's the CLI version of Wireshark. It's very similar to TCP_dump, but not. It's the same but different, right? It's a command line tool. It processes PCAP files or PCAP-NG files or even other capture file formats that Wireshark supports. It uses the same engine, so it's compatible with Wireshark. But while TCP_dump shows you some information, tshark shows you all protocol decodes. So everything that Wireshark decodes, tshark will decode too. And that means it's stateful, it does reassembly, and it supports much more protocols than TCP_dump does. I use TCP_dump a lot as well, just to capture, and then I get my files to tshark. And tshark uses dumpcap as a capture engine, just like Wireshark does. So Wireshark and tshark don't capture themselves; they just give a job to dumpcap to do it for them, because of the privilege separation. And but in this presentation we're not going to capture, we're just going to use it as a viewer. Some standard options are -D for showing the interfaces, -I for using a certain interface, -C for just capturing a small amount of packets, -N for name resolution, -L for line buffering. Well, if you use tshark -H, you can find all these options, and it tells you what options are available. But these are the ones that I use a lot. Name resolving, if you want to do timestamps in a certain format, usually I do -T and then A for wall clock times. And if you have a protocol that runs on a certain port, just like you have in Wireshark decode S, in tshark it's with -D, and then use the port and what protocol you want it. So in this way, every traffic from port 8080 will be decoded as HTTP. We're going to see an example of that later. And if you want to use a certain preference value, like reassembly on or off, you can do that with -O. You have to find out your preference value, your preference name, and then use a value that you want. I can show that later. You can also use -C to select a certain profile. So if you have built a profile in Wireshark, you can select it with -C, -C. There's a lot of output formats in tshark. The standard one is just give one line, like the packet list in Wireshark. But if you want to have full decodes, you can use the -V, or you can use -T for other formats. So the default is to use the column preferences as it is using in Wireshark. With -V, you get the full decodes. You can even add the hex dump if you want with the -X. And if you only want a decode of a certain protocol, you can use -O to select the protocols that you want expanded, and all the other protocols will be collapsed. I will show you that in a minute. There's PDML, which is a version of XML. So you can use an XML format if you're able to parse XML with other tools. There's also JSON output these days. It wasn't in, I think it was added like 2 years ago or something. And there's if you want to push stuff into Elasticsearch, then the EK format is used. So that's it should have been ELK, I guess, but it's EK. The one that I'm most interested in is to select specific fields that I want. So with -T fields, I select that I want to. I choose to select a couple of fields. And then the fields that I want, I have to add with -E and then a field, etc. So you can select exactly the fields that you want and put them in the output. And they will be separated by tabs by default, but you can select another, if you want to have them comma separated or anything else, you can select a separator. Again, look at tshark -h, because there's quite a few other options that you can use with -t fields as well, like if you want to have headers or not, if you want to have quotes around stuff or anything, that can be selected on the command line as well, which is particularly useful if you want to automate stuff. Then there's built-in statistics, just like Wireshark has statistics. There's a protocol hierarchy that you can show on the command line as well. You've got the conversation options that you can show on the command line. There's I/O statistics that you can show on the command line. So basically this command does is it gives you a statistics every 10 seconds, and it tells you how many IP packets were seen, how many ICMP packets, how many UDP packets, and how many TCP packets. So that can, if you want to have like a baselining application, you can use that. And there's follow stream. I haven't used it myself yet on the command line, but there's follow TCP stream or follow HTTP stream on the command line as well. What you do is you select follow, then the protocol. This can be HTTP as well, or SSL or UDP. Then a format. In this case, I chose ASCII, but you can use hex data as well. And this is a stream number that you want to do the following on. I can show that also. So let's have a look at what this does. I've got a little copy and paste list here, so you don't need to read this. It's just for me. But I've got a. Is this readable from the back? Large enough? Yeah. Okay. So let's go to the lab files, and let's just start with a very small example. The reason it's not quick at the moment is because I didn't turn off name resolution. So I tried to do name resolution. If I do it like this, it should be quicker. Well, my laptop's not, it's a very old laptop. I only brought the small one because I'm going on holiday after this conference, so I didn't want to bring my full laptop. And I see that my CPU is hogging something. Oh, that's a QuickTime player. Thanks, Angelo. Okay, so everything will be a little bit slower today, but that's okay. So let's see what happens if I do a full decode of this trace file. As you can see, there's a lot of information on my screen now. That's the full protocol decodes are visible, and but what you can see is that it uses all the fields, like my IP layer is expanded and my TCP layer is expanded. So let's see if I do a filter on it, HTTP request, what it will show for just one request. I know there's only one request in this trace file. So you can see that it expands all layers. So if I use -O HTTP, it will reduce that into this, where you can see that only the HTTP layer is expanded. So if you're only interested in a certain protocol to be expanded, you can use -O, and all the other protocols will just have the summary line, which is quite handy. I'm not going to show you all the PDML output. I'm going to show you the difference in length of all of these. So let me just put them all in. And then I'll show you the difference. So I've got a capture file that's only a little over 3K. And it shows you with tshark, just with a summary line, it shows you 1287 bytes. With my capital V, it shows you 45K of information, and with the PDML, the XML output, it shows you 200K of information. So it really expands and bloats your. So be careful in using. Choose your right option for your job and not. Yeah.
following your command exactly. I'm running a Ubuntu.
Yeah.
And the number of lines captured seems to be different from yours.
What version are you using?
I just download a tshark. I mean, apt get tshark. I mean, just as later after this we can run.
Yeah, probably that's the version because different versions use different, do different dissections, so the output can be different. My version is 2.5.1, and you probably have a 2.2 version or something.
Yes.
Yeah. So, yeah.
Right.
So probably that's the reason why.
Okay, thank you.
Yeah.
I just downloaded it.
Okay. Back to the presentation. Okay, so we had some. I didn't show you the JSON output, but well, let's see what the JSON output does. JSON, and I'm going to use one packet. So you can see it builds up a JSON object that you can import in other tooling if you want. I'm not quite sure what the difference is between a JSON and the ELK output, but there's a little difference which makes it possible to put it into Elasticsearch. And if I do a word count of it, that's like in between the PDML and the capital V output. Okay, back to some protocol preferences. If you want to add protocol preferences to your command line, let's show it with how to do SSL decryption. So I've got an SSL file in there, and I need to decrypt it. I think this is a little different in my. I'm not sure whether I have it in here. Yes, I have. So if I read the SSL PCAP, it shows you that it is SSL traffic, and you see that there's application data that's encrypted, so I can't read it, which is of course good because I'm not supposed to read it, but I'm the lucky guy that has the private key, which means if I supply the private key in the right way, let's see, it's over here. So you say SSL keys list equals your server IP, your port, and the protocol that's in the SSL session, and where your key file is, then you're able to do decryption, just like you can do in Wireshark. And that means I'm now able to see the HTTP requests. And if I want to see the whole request, of course I can use -V again, and that will give you the decrypted. So as you can see, it's TCP, then SSL, and then SSL hands over the data to HTTP after decryption. So that's how you pass command line or protocol preferences to tshark. So also what you want to do is either turn reassembly on and off, and that's in a TCP preference. If you want to know what the certain name for preference is, you can use tshark -g current prefs, and it will show you the whole list. But I'm only interested in TCP, so I'm piping it to egrep, and I'm searching for something that starts with either a hash sign for if it's disabled, and then TCP. Needs to start with the hash sign. So this gives me all the TCP preferences, if I'm correct. See, those are all your TCP preferences. So if I wanted to do reassembly, you see that's enabled by default. If I want to disable it, I just use TCP desegment TCP streams :false, and then the reassembly will be disabled. Okay. So then I'm going to skip this example, but you can do it yourself. It's in the presentation, so if you want to do it yourself, you can. This is where you see the difference between if you save packets with the reassembly on or off, it will give different results. So be careful if you save packets after selecting them, which ones will be saved. So I leave that as an exercise to you for doing at home. Then there's of course the statistics, the I/O, the protocol hierarchy, conversations, and conversation at the IP layer, and some statistics. So let's see what they do. Let's see. So here you see the same statistics as Wireshark will show you when you do statistics protocol hierarchy. So all packets are Ethernet, then there's IP layer, TCP layer, there were some mails being sent, some mails being received, and there were some ICMP messages. So it gives you an overview of the file, and I can do the same for conversations at the IP layer. Who is talking to who? Oh, my screen is not wide enough, but it's one table with all the same as you do it in Wireshark. At the TCP layer if you want. And by default, this table gets sorted by the most, I think it's the most packets, not the most bytes. Yeah, see, it's sorting by frames, not by bytes, because these bytes are more, but it sorts by frames. Then the last one, which gives you an overview of all the protocols in here. So it tells you which column is which filter. And then for each filter, it shows you a column with how many frames are matching that filter and how many bytes were matching that filter for each interval that you chose. So I chose a 60 seconds interval, and so it shows me each minute which bytes were transferred for each protocol. So that gives you, if you only have the command line and you need to get an overview of your trace file, this is the quickest way to get the information and know what's in there and start working from there. Other questions about tshark?
Those examples, right? I'm trying to run from the Windows. I don't have that option / for Unix.
Yeah, I usually use Cygwin under Windows. I know the PowerShell commands are really useful as well. And Graham did a presentation at SharkFest Estoril in Portugal about how to use PowerShell. So this presentation is being transformed into a PowerShell presentation. So you can look that up on the retrospective side of the SharkFest Europe. I'm not a Windows user, so I'm...
Who did that again?
What?
Who was it that did that? PowerShell?
Graham Blois.
Okay.
So it's on there. Yeah.
I understand that using the -e option, you can decide which column you want to display, right?
Yeah.
So is there any option to display the information field using the fields?
There is, yeah. I'll be using the -t fields option later. So, but if I don't show it, remind me that I show you the column info. I'm not sure what the, I think it's _ws.columns.info, something like that. We'll look it up. Okay, any other questions for tshark so far? Then I'll continue with dumpcap, which is of course used by Wireshark and tshark for privilege separation. You don't want to run your capture engine with root. You don't want to run your dissection engine with root privileges, and often you need to do the capturing with root privileges. But you can use it separately, and all the options that you can use are similar to the ones with tshark, of course, because tshark just hands over the options to dumpcap. And it's pretty fast. It just dumps your traffic to disk. It doesn't do any dissection. It doesn't read the file. It just takes a packet and puts it to disk. And it's stateless, which means it doesn't keep state of sessions, so it won't increase your memory usage, and so you can run it forever. I've been running, at some customers I had it running for months at a time, just with a circular buffer, like this. You choose your interface, your capture length. You say I need files of 16 MB per file. I usually use 64K these days. Then how many files, and you write it to a ring buffer, which means it creates a file of 16 MB, then it creates the next file, and after 1024 files, it deletes the first one, and it keeps going. So you know this will only take 16 gig of your hard drive. So you know that you won't run out of disk space, which is quite handy. Then there's cap infos, which shows you information about the pcap files, and you can get all information, or you can ask for specific information, and you can put it in a table form, which is quite handy if you want to compare for a selection of files, when they were made, and how many packets are in there. So it shows you basically the same thing as in capture file properties. I think it also shows you more information because it shows you MD5 and SHA-1 hashes. Are we still doing SHA-1, Gerald? Do you know?
Sorry?
Are we still doing SHA-1 here in the hashes, or already SHA-256?
We dropped MD5.
Yeah.
We're doing SHA-1, RMD160, and SHA-256.
Okay. So you can get a fingerprint of your file, so you know that it hasn't been changed, and stuff like that. And you see here, this is the whole, all the information. Well, at that time, because this was done in 2008, so it's tshark for cap infos in 2008. So it shows you less information than it shows now. Which you can select, like the start time and the end time, and you just get the dates. I use it quite a lot when I get capture files from a customer. You get like 6 files or 7 files, and you have got no clue when they were made. I just use a little command to see what the start and the ending time of each file was, to see if they were made at the same time, to see if they were made at the time the problem occurred, etc. I'm going to show you cap infos in a minute. Then there's editcap. And you can use editcap in 2 different ways. One way is to select packets, so you don't change the packets, but you select them. And the other way is that you can change packets. So let's first see how you can select packets. You can use it to select a frame range or time ranges. So this is the first example. Is I want to have. So the -R means. By default, editcap will delete your frame range. If you select the ones that you need to put -R in front of it. So this one, it creates a file with frame 1 to 1000, to 1000, and 2001 to 3000. So the rest of the capture file is being deleted. And if you use it like this, you get a time frame that you can that you select, which is quite handy if you have multiple files. They start at different times and you want to have them clean and to be able to compare them. Just use the time frame, and then the files have the same time period. You can split a file in chunks, either by a count of packets. So in this case, example.cap. I need to change that. I changed all my file names to pcap. I need to change my presentation as well. I did a search and replace yesterday on cap to pcap, and then all edit cap became edit pcap. Like, what? That doesn't work. So you can split on chunks of certain amount of packets, or you can do it with time, which means in this case, in the second case, the file will be split up in files of 1 minute each. Then you can remove duplicates, which is very handy if you made the mistake to capture on a VLAN. It's a span port and every frame is seen twice. You can use editcap -D on your capture file, and then it will remove all the duplicates. If there is really a lot of frames and the duplicates are not very close to one another, there's an option to increase the window, but it makes it slower, but it detects more duplicates. So that is handy as well. Then there's editcap to change packets. We can change the snap length. So if you capture the whole frame and you want to provide the capture file to another company and you want to remove everything after a certain length, you can just use the snap length. Or if you have seen that the problem is not at the application layer, but you still want to keep the files, you might want to make them smaller, you can just slice them to smaller size. You can change the timestamps, which is very handy, because I often forget to synchronize clocks before I start capturing. I guess everybody has that problem, or just me, I don't know. But you can change the timestamps afterwards by using this. So this means for every packet, deduct 1 hour from the actual timestamp that's in there and put that in the trace file. Of course, usually you don't have that nice a number to subtract, but it gives you the example how to use it. Then you can change the link layer type. I've almost never used that. There are some use cases, but or you can change the file type. If I have an old DOS sniffer file and I want to make it a PCAP file to be able to use it in other tools, I can use this to turn it into a PCAP file. And you can do that for all the capture file formats that Wireshark supports. So you can translate the files. Then when we split the files, it's also nice to be able to combine files, and that's where merge cap comes in.
Change cap. Is it possible to change packet data?
Not with editcap. What kind of example do you have for that?
Like the use case is for like security or banking customers who don't want to give us IP addresses. They don't want to do captures, or they don't want to give us the captures when they are showing the IP addresses of their internal.
Yeah, that's anonymization. And Jasper Bongert made a good tool, Trace Wrangler, to do that. You can use Scapy to do that yourself. It's a Python library, but you need to make your translations yourself. So Trace Wrangler is at the moment the most capable tool of doing that. But it's very difficult because when you do anonymization, you want to have a certainty that it doesn't leak information. So by default, it needs to strip everything and just give you the information that. So it's a difficult process, as you probably have experienced yourself.
I will say that Trace Wrangler saves me hours and hours.
Yeah.
You can say keep the subnets the same, change the host part.
Yeah.
You can say anonymize the MAC OUI if you want, or keep certain parts of it the same. The default is to strip out anything it doesn't understand.
Yeah.
So there's no way. It's a very security-focused tool, and the whole purpose is to anonymize.
Yeah.
Right. But keeping one of the problems with the anonymization tool is it creates a new timestamp. So now when you look at the timestamp, it's off but you can keep all of that. So again, it's a very handy tool.
Yeah. It's Windows only, but more questions about anonymization or changing packets? No. Okay. So with merge cap, once you split things, or you've made a ring buffer and you selected certain frames from the ring buffer, you might want to join them again into a new trace file, and you just use it like this: merge cap, the output file, and then the input files, and it can be, of course, more than two. It can be a whole list. It combines all the packets, and it uses the timestamps to correct the order of the packets. Usually there are packets that are in trace files that have different time frames, so it doesn't matter. But if there are packets if there are trace files that overlap by time, they will be merged based on timestamp. There's also an option to just append packets, so it doesn't look at the timestamps, but I've tried it and it's not any quicker than using a timestamp, so I never used it to just append things. Okay, bless you. So we're going to do a few demo commands. Let's see. So I split up my mail.pcap file in files of 60 seconds. And as you can see, there are several files. If you look at the timestamp, they're more or less 1 minute apart. That's because there are not as many packets that it really fills up all the seconds. So there's a little difference. But if you look at the file sizes, you see that there's different sizes. If I do cap infos on this, and I use -t to get a table, and I'm interested in the start time and the end time and the amount of packets, and I do that for all temp files. No. Well, let's do it only with the start time, because otherwise it will still too much. Let's see. Oh, that's because the file name is... Wait a second, what's happening here? It's showing me also that's strange. There we go. I needed to remove the space. So you see all the files. There's different amounts of packets, and if I look at the time, and now I can do like this. You see that it's 1 minute intervals. You can see that in the timestamps, more or less. Well, it's exactly 1 minute, but not every minute is filled with all packets. So this is based on timestamps. I can do the same based on 1,000 packets per file, and now you see that it's split in 1,000 packets per file, and then of course the last one is not complete, but that doesn't matter. So now I can merge that back. Since this was pcap, and merge cap by default uses pcap and g these days, I need to add something. I need to add that it needs to save it in pcap, because I want to compare the files. So I'm going to save it in libpcap format. Temp. So now I have a mail. So the same size. If I compare them, mail, pcap, and mail new, and I think they won't compare. They differ, and that's because the default capture length has been changed in the versions. So if I do cap infos on mail, I get a capture length of let's see, packet size limit 65535, and if I do that on mail new, I get. But apart from that, the files are the same. So you can split it and merge it, and you still end up with the same stuff. Let's see. Okay. Well, I merged them also, so let's see what we can do to edit timestamps. The case is I want the first packet to have exactly this time setting, so I need to calculate my delta and then use that on the file. So let's see. So let's first get an overview of the timestamp of the first packet. As you can see, I just selected one packet, whole protocol tree, but only for the frame information. Now I can see that I need to subtract 27 dot whatever seconds. So if I use this command, it will subtract those seconds from every packet. And if I now look at the first frame, but then of course the mail new, you can see that it now is starting exactly at the whole minute. So this way you can change the capture file. And let's see.
Okay, is there an export mode in T#?
An export?
Export mode, yeah. You know, Wireshark they have this analyze expert?
Expert information. I don't know. Let's see. I never used it, so. Yep, there is.
-Z. Okay, thanks.
-C expert, and you can select which expert levels you want. Yeah. I was pretty sure it was there, but I didn't know. So, yes, it's there. Okay. That's for the demos for the simple options of using the command line tools. Any questions about that before we go to pipe the output to other tools to see what we can do to mangle stuff? No? Okay. If you want, like I just did, if you don't know if an option exists, you can also always use the command line -H option, and then you get all the information that you need. Let's see if I just use the man page, but I could also use. As I did tshark -H, maybe it had an expert as well. I don't think so. No, but tshark -H will give you all the options in a nice overview. So as you can see, there's lots of options to do. And if you look at this, here are the options for all -T fields options. So there's quite a few options that you can use. Okay. So there are new options added to each command. No, not every day, but once in a while there's new options. So you can use -H to, if you do it once in a while, to see if there's anything that you haven't seen before. Check it out and see what it does. The man pages are really useful. And of course, if you have a question, you can go to ask.wireshark.org and ask a question about it. So, if you want to post-process the results of tshark, then there's a couple of useful commands. I'm going to go quickly through it because it's basically a Linux course, which I'm not here for, but these are the commands that I find useful to work with. Of course, the pipe command, the redirect, a for loop, or the backticks to execute a command and use the output of it. I'm going to use those in the examples. Cut to select stuff. Well, I'm going to show each command in its own page. So command line piping, you do with a pipe command. Redirection to redirect output to a different file. Looping to loop through some values. And backticks to create output of a command and use that in the next command. So, for instance, if I'm going to loop through all the files in this directory, I can do it like that. And of course, you can assign variables. So, if I have a certain file, I'm going to put it in a variable, then I can use that in another command. With cut, you can select fields or character ranges. Very useful. With sort, of course, you can sort the stuff. I'm going through it really quickly. If you want more information, use the man pages or just experiment. But I want to show it a little bit before I use it. And so with unique, you can deduplicate things or you can count things, which I'm going to use extensively in the examples as well. With translate tr, you can translate stuff, so you can translate a space into an underscore, or you can change characters, and you can delete characters, which is handy if you want to if you have a Windows formatted ASCII file, you want to delete the character return, you can use tr for that. And that's this example. That's how you delete the character return from a DOS file to. So it's Stream Editor is very complex. I only use a very small amount of functionality of it, but it's very powerful in changing information in your file. Maybe that's also what you can use if you want to anonymize stuff. No, he's reading. You can just use this to anonymize stuff as well, but be careful that you don't change the character boundaries. You can extract stuff. We're going to see that in the examples. Awk, also very powerful programming or scanning and processing language. I use that quite a bit. It's a full language, so you can write whole scripts in Awk. I usually do it like a couple of lines and then I'm done. But you can use it in a nice variety of ways. This I use quite often. What it does is it gives me my net side information. I'm only interested in lines that start with TCP. Give me the TCP state. Well, it's 4 on some systems. On my Mac it's 6. But it gives you an overview of all the states. You sort them and you count them. So it gives a nice small overview of the state of all your TCP sockets. This is an example of how you. There's a tshark command here that outputs ports, and then I translate that into a display filter. I'm going to use that in the examples as well. Then there's Q, and I'm not talking about Q from Star Trek. I'm talking about Q, the command line option that makes it possible to run SQL commands on your text files. So the example that I just did with Awk, you can do that with Q as well. You just get the netside output. I'm reading from standard in, and I'm going to use only the lines where the first field is has TCP in it, and then I'm going to group by the sixth field, which is the status, and I'm going to select the status and the count of the status. So this gave me an overview of the. I find this very useful. I've been using this recently since like a year or so, and it's quite useful to, if you have like log files with anything in it, just use Q on it, and you don't need to transfer to anything else. Of course, you need to brush up on your database skills. But okay. Then, of course, if all those command line piping doesn't work, you have a job that's too complex, you can, of course, use scripting to script around everything. And, well, you use your favorite language. I'm kind of a Perl guy. I'm trying to become a Python guy, but I'm still in Perl world. So, but choose your language of your choice and then just post-process the data that you want. Let's see how that works. I have till, Anselo, what time do you have? Till 10, right? Okay.
10.
Oh, we've got plenty of time. So some cases using command line piping. For instance, counting HTTP responses, making a top 10, create a list of all sessions within a certain cookie, or use scripting to get all the sessions for a user. So what this basically does, I have some HTTP traffic. There's a session cookie of a user, and what I want to do is I want to extract all the traffic from this certain user from this trace file into a new trace file. So there's multiple users in a trace file. They're only identified by a cookie, and I want to extract that. That's what I'm going to do in these examples. So let's start easy. Let's count HTTP response codes. So what I said earlier, imagine what you want, see what you have, and then experiment how you can do it. So the output that I want is a table with HTTP response codes and a count of those, and the input is a capture file with HTTP traffic. So let's see how we can do that. Oh. So first of all, I need the HTTP response code. That works. So I've got the HTTP response code here, but I need to post-process this. So that's where -t fields come in, because I'm only interested in the response code field. So if I do the same with the -t fields and then the response code, I get, of course, a list of all the response codes. Now the only thing I need to do is use that output, sort the output, So I'm sorting the output on. Let's do one step in between. Sort by more. What it will do, it will sort the output into a list of response codes, and then with unique -c, it starts counting. So every time there's a new response code, it will start counting. It will reset the counter and start counting all over. So this is an overview of the response codes. It's a very simple example, but it gets us to where we need to go. So what did I do? I print the response codes, I count, and I make a sorted table. And this was the command that I used. What did we learn? We learned how to use -c fields, and we learned how to sort and count the. So now I need to count the top 10 requested URLs. So first I need a list of URLs that have been visited, and I want to sort it and I want to count it, and the input again is a capture file. So the steps I'm going to take is print the host header and the request URI, and I need to remove everything after the question mark because those are the query strings. And I want to combine the host and the URI and form it into a normal URL. We don't need to do that anymore because there's now a field that's HTTP full URI, so we don't need it anymore. But if you don't have that, this is how you can do it. And then I need to count and make a top 10. So let's see how we can do that. So let's first see how we can get the URI. If all goes well. And now we wait. This is strange. This won't work, right? Or is this also slow now? There's a difference in my CPU, so there's what is happening. Oh, there we go. There was some kernel task in the way. There we go. We have the HTTP host and we have the URI. And now we want to combine that into one field. Or first we're going to strip the query. And I can use set to do that. What this means, I'm going to substitute everything from a question mark and any other characters until the end of the line. I'm going to substitute it with an empty space. So if all goes well, and it doesn't, then I shouldn't see, oh it does, I shouldn't see the question marks again. So now we stripped the query from the URI, and now we need to combine the two into, and this one doesn't work, I know that because I've done it before. I need to strip or combine these two, but the set doesn't understand the \t for a tab, so you need to do Ctrl+V tab to make that work. So there's my full URI. So it's the host combined with the file name. And now that I have that, I can pipe sort, pipe unique -c. This gives me an overview, but I was interested in the top 10. So after getting the overview, I'm going to sort again in reverse numerical for a reverse list. And then I'm only interested in the top 10, so I'm going to do head. I use this combination a lot. The sort, unique, count, sort again, and then head. That's the top 10 for anything. Oh, there's a head. Yeah, the head is just for working the thing out. Thanks for pointing that out. I didn't want to copy the command from here because then I needed to change the \t to a tab again, but I forgot about the head. It's very relaxing to use an old laptop because it gives you time to think. Okay, so this is the result. I've got a top 10 of the most visited URLs in this trace file. So the total command was this, and what did we learn? We learned how to remove stuff with set. We learned how to transform stuff with set, and we learned how to make a top 10 list by using this combination of commands. And let's see. So this is the full command. That's a duplicate slide, I guess. Yeah, we already saw that. Okay. Oh, now I see why. This is just an overlay on the last slide. This is not necessary anymore because we now have the HTTP request full URI field. So all the transformation that we did is not necessary anymore. But I kept it in here because it shows you how you can do it. If there is not a field for something that you need and you want to combine stuff and transform stuff, this is how you do it, and then you get what you want. So now let's move on to how to select all the sessions with a certain cookie. So a problem that I have, so I have a problem. I know in which session a problem exists, so I know the cookie of the user, but I want to have the full user session with all packets in it. So the output should be a new capture file with the full TCP sessions that contain that cookie, and of course I have an input file with HTTP traffic. So the steps I'm going to take is I'm going to select packets that contain that cookie. I'm going to print the TCP stream numbers, create a new filter based on those stream numbers, and I'm going to use that filter to extract the TCP sessions out of the original file and save them in a new file. So let's see how we do that. So first of all, let's see if that cookie is really in the file. Yes, it is. And as you can see, there are several GET requests with this cookie. Now I'm interested in what are the stream numbers of those sessions. As you can see, they're all in different TCP streams. So I have multiple TCP streams that I want to combine into one trace file. There is not a number missing here, but if you look further, let's see. As you can see, there's gaps here. So not all TCP streams have this cookie. So that is indeed a selection. So let's transform these TCP stream numbers into a filter. As you can see, this is now a valid display filter, and the way I did it is to use to take these numbers and I awk it. I'm going to print something and then TCP stream equals something. Something is separator, but that's empty at first, and $1 is each first field on each line, which is the stream number. After the first entry, I use separator is equals a double pipe, which means the next run there will be an OR in front of it, and this means I only have an OR in between the filters and not one on the front or in the back, which kind of kills your filter if you want to use it automatically. Of course you can change it yourself, but I want to use this filter directly into a new filter. That's what I'm going to do in this next session. So this is the command that I will run. As you can see, there's backticks here. There's a backtick here, and there's a backtick there, which means this command gives me output like we saw before. It's a valid display filter, and I'm going to use that output as a new display filter for this command. So now I run tshark twice, one to create a filter and the second time to use the filter to create a new file. So now I have the original example.pcap, which is 900K, and 300K out of that were sessions in which the cookie was present. I won't do a verify step. Normally you need to do a verify step if it worked correctly, because you can bite yourself in this way as well. But you need to verify your results, but I'm not going to do that now for time reasons. I'm just going to look at the file sizes and the amount of frames. So, but please check your results before sending it out somewhere. Okay. So the command that we used is this, and now I made a distinction in colors between the two tshark sessions. The blue one is the one creating the filter, and then this one is the one using the filter to create a new file. And the backtick, of course, has this color because it belongs to that session. So what did we learn? We learned how to use the output of a certain tshark command or another command that generated a filter and use that as a display filter for new commands. We created a filter from a list of streams. So this is a very handy trick to create a filter that doesn't have an extra or in between or at the end of the beginning of the filter. This was, of course, for one cookie, but how did we know the cookie? We only know the username, right? Somebody calls us and said this user had a problem, so we need to find out what the cookie is for this or what the cookies are for this user. So the next problem is a user calls me and has a problem. It has multiple sessions, so it logged in, did something, logged out, then it logged in again, got a different session cookie, and did stuff. I'm not sure in which session the problem was, so I need to collect all the cookies. These are the steps. I need all the cookies for a certain user, and then I create a capture file per session cookie, and merge all the new files into a new file. Or I create it. This is the way I do it now, but you can also create, of course, a combined filter for all the cookies in once. But this makes it a lot easier to understand. So that's an example that I made a whole script out of. So let's view the script, example 4. So what is the script? I've got a file. I read the file from the first command line argument. I read the user as a second command line argument. I'm going to tshark this file and look for traffic that contains the username. You need a more specific filter if you do it on your own, but in my case this works. But of course, if it's a username that is in other HTTP traffic, this will mess up. So you need to have a more specific selection of the username. Then I'm getting only from the cookie because I'm printing a cookie. Let's see, where do I do that? I'm printing the cookie, so I need to post-process the cookie to get the username or the session cookie name. Then I create a new the file name for each new cookie name. I'm processing the cookie by using the command that we just had. This is the same command, but it uses the cookie instead of a fixed cookie name. And after it's done all the cookies, it merges all the cookie files and then saves it to user.cap. So that's how we... so if we run the script, example, let's see, example 4, and the file was mail.cap, no, example.cap, pcap, and the user is Sake test1, I think. There we go. So it creates a new trace file for each cookie that this user has used, and then it combines those three into a new trace file. So now we see that, and it's not cookie. I'm merging to user. So it's Sake test. So out of the that's interesting. Something didn't work right because my example file has less frames than my new file. So something didn't work. It's kind of strange. Also, the end time is different. Let's remove. I think I had other. That's true. I had other temp files in there. So let's do the script again. See how you need to check your results. I always verify when I do something. I verify if the result is something that I can expect. Otherwise, that's better. Now the time frames are within the same range. Like this is a selection of that, and these frames are a selection of that. So I had other temp files in there that messed up my first attempt.
That was a 2-day effort for me, what you just did in 10 seconds. Do exactly that.
Yeah? You should have visited my session earlier. Okay.
You did that for a customer because you were troubleshooting and you needed to find out which cookie or which section.
No, I did this because I wanted to show you how you can do stuff.
The problem that I had was intermittent failure for an application, money transfer application.
Yeah.
And the cookies were getting reused.
Yeah.
And the system would say, oh, I can't let you do that because I already saw you.
Yeah.
So it's a bug in the application where the cookies were being reused, which is actually a pretty serious bug. But this is why it was such an intermittent problem. And my team and we did that manually.
Yeah.
And we just happened to notice the cookie, like, I think I recognize that.
Yeah.
And then went and investigated, and it was a 2-day effort.
Yeah. Call me.
I'm sorry? Yeah, you know what?
Yeah, that's why you see the power of this is something you can't do with Wireshark. You need to use command line scripting to do stuff like this, or use other tools that have this functionality in it. But there's so much things you can think of that you want to do, and not all the tools have all the options. So I use tshark a lot to do stuff like this. So what did we learn? To loop through things, to assign a variable, to select fields, to merge output, and that's it. Oh, that's what we learned, sorry. So, last example, show some metrics per URI. So I want to create an overview of the minimum, average, and max response times per URI. The output should be an overview, of course. The input is, again, the HP data. And now I'm going to use Q to do that. And the problem with, in Wireshark, there's no link, or there's not in a single packet, there's no URI and a response code and a response time. Those are in separate packets. And how do we combine those? Well, that's where SQL comes in, right? We can join based on certain index fields. So in the request, we have a frame number, and in the response, we have a field that's request in. So that's the link between the request and response. So if I make a list, let's do if I read here we have the frame number with a request. And of course, if I do like head -20, you can see the question mark again. So I want to remove the query string. We've seen that before. We can do it like this. These are all my requests, and I'm going to forward them to redirect them to a file requests. So now I have the requests in one file. I'm going to do the same for the responses. Let's So this command gives me the request in, the response code, and the response time, the HTTP time. Of course, it depends on your protocol preference whether this is the response time from the web server or the response time plus the transfer time. I leave that exercise to you, but you need to choose whether you want to do reassembly or not to make sure that you have the right response time in this. But the principle is the same. Or I can, let's see if we, I'm not sure what the current prefs, what was the preference again? DC, okay. I'm going to use I'm only interested in server response time, so I'm going to disable reassembly and disable reassembly. And now I'm going to save that to a file too, responses file. And now I'm going to do the magic with Q. Which says, give me all from the, okay, I'm going to read from file request as request, and I'm going to join that with response as response. And the way to match them is the first field in the request needs to match the first field in response. Once I've done that, I'm going to select the second field in request. I'm going to count those, the minimum of the third field in the response, and the average of the third field in the response, and the maximum of the third field in the response. And those will be grouped by the second field in the request, which is the URI. And this gives me an overview of all the URIs with the amount of times that it was seen in the capture file, the minimum response time, the maximum response time, the average response time, and the maximum response time. So I create a text file with all requests, with all responses, and join them, and that's what the result is.
What was the common field index you used to join it again?
In the request I used the frame number, and in the response I used the HTTP request in field, which is binding the two together. And this is a simple example, but of course you can, for your own problem, you can decide for yourself which fields to use and how to combine them. So what did we learn? We learned how to use Q to combine multiple outputs with a join command. That's it's time. So any questions? There's an exercise in here. Wait a second. This exercise is a challenge for you. If you want, you can do it. There's a mail.pcap file, and there's pop request in it. And what if you want to have this output? Try to figure it out, how you can create this output. And send it to me if you want, and I don't know. So let's do a summary, and then I'll do the Q&A. So Wireshark is very useful, but the command line tools are very useful as well. When you do scripting, or it can complement the GUI, and you need to use building blocks. It's Linux, so piping commands to another command makes it possible to do really valuable stuff. And that's what it is. Any questions? Okay. If you still have questions afterwards, my email address will be in the presentation, which will be online. So feel free to email me if you have any questions.